guys. Today we're going to be doing some special right triangles again. I noticed when I was looking over your homework that some of us were missing some things that we normally wouldn't miss. Okay. So I just thought we would do it again. I wanted to show you, I've got this table right here with my special right triangles in it. This was in your notes that you should have looked at yesterday or the video from yesterday. Um, when you do special right triangles, so the ones with 45, 90 or 30, 60, 90, it is very, very important that you leave things in this form. You use radicals, you use fractions, and there are no decimals, okay? I actually have a picture of this that I have attached as well. You probably want to get this in your notes somewhere, okay? But what I want to do with you right now is just to go over some examples with you so you can see what this looks like and what it is that I'm expecting you to do. Okay, so let's go take a look. We're actually going to do these four problems. Okay, these are actual problems from your assignment later too. So first of all, let's take a look at number one. This is a 45, 45, 90 triangle. Because it is a 45, 45, 90 triangle, this is an isosceles triangle. So you should be able to tell me what B is right away, okay? Because it's isosceles, you know that those two sides are going to be the same. Now, we do need to find out what A is, and you have two choices, okay? Choice number one is that you can use Pythagorean theorem, okay? But this is not that unit. This is not what we're talking about. This is not what we're doing. So option number two is to use trig, and that's what we're going to do for this one, okay? So I need to find out what A is, and I can use either 45-degree angle. It doesn't matter. They both end up being the same thing anyway. But let's go ahead and do the sine, okay? So the sine of 45, if I'm looking at this 45-degree angle, it's going to be opposite over hypotenuse. So I'm going to put 2 root 2 over A, okay? Now, the sine of 45, if I look at my chart, is root 2 over 2. So I'm going to replace the sine of 45 with root 2 over 2, okay? And that's going to equal 2 root 2 over A. Now I'm just going to do a little bit of cross multiplying, some algebra, move this problem out of my way. So let's go ahead and do that, okay? So 2 times 2 root 2, and then root 2 times A. So 2 times 2 root 2 is 4 root 2. And then when I divide by root 2 to get A by itself, these are going to cancel out, and A is equal to 4. Okay, so B is 2 root 2, A equals 4. Excuse me, let's go do number 2. Okay, so number 2, same thing. I have a 45-degree, for a 45, 45, 90-degree triangle, but I don't know what my two sides are. So once I find one of them, I should be good. Okay, let's go do the sine again of 45. Okay, so I'm going to do the sine of 45. That's going to equal my opposite, which is going to be x, over my hypotenuse, which is 4. Again, the sine of 45, if I use my little chart, right, the sine of 45 is root 2 over 2, and that equals x over 4. I'm just going to do some cross multiplying and get x by itself. So 2x is going to equal 4 root 2. Divide both sides by 2 and simplify this, and I get 2 root 2. So x is 2 root 2, and since it is an isosceles triangle, this is x, this is y. It's isosceles, those are the same lengths, so I really only have to do it the one time. Okay, remember, no decimals. You need to keep things in radical form and or in fraction form. Sorry, that was my timer going off telling me it's time to have another cup of coffee. All right, let's take a look at number 7. Move this out of the way for now. All right, so number 7, this is a 30, 60, 90 triangle. Okay, and so this time I'm going to use what I know about 60 degrees, and try to find the other two sides. And yep, it looks like I left off a measurement. So that side, excuse me, is 16. All right, so let's use 60 degrees. So I'm going to do the sine of 60 degrees. That's going to give me the opposite, which is x, over hypotenuse, which is 16. Okay, again, using my chart, the sine of 60 is root 3 over 2. So I'm going to substitute that in. And then cross multiply. So I get 2x equals 16 root 3 and divide both sides by 2. And then simplify. So I get 8 root 3. Okay. Now I need to go find this side y. So I'm going to do this, the cosine this time of 60 degrees. And so the cosine, remember, is the adjacent. And so I'm going to do adjacent. So y over 16. Okay. Using my chart, the cosine of 60 degrees is 1/2. Do some cross multiplying. Whoops, I'm off the chart, guys. 2y equals 16, so y equals 8. Okay, so number 7, x is 8 root 3, y is 8. Okay, last one, number 8. Excuse me again. All right, so here we go. We're going to go do, use our 30 degrees, and we're going to find u and v. Okay, so I'm going to start. I don't know why I always seem to start with sine, but let's do the sine of 30 degrees. And that's going to equal opposite, which is 2 over hypotenuse, which is u. The sine of 30 degrees is 1/2. And so I cross multiply and I get u to be 4. Okay, now let's go find v. So for v, this time I have an opposite and an adjacent. So I'm going to do the tangent of 30 degrees. By the way, you always want to do what is in the triangle originally, because what if you were wrong? What if you accidentally got the wrong answer? Do you know what I mean? And so you definitely want to go back to the triangle. You have a better shot at getting this right, okay? All right, so 30 degrees, I'm going to do tangent. So I'm going to do opposite over adjacent. So the tangent of 30 degrees, if I go in here and look, is root 3 over 3. So I'm going to go substitute that in, root 3 over 3. And then solve. So I get v times root 3 and 6. I'm going to divide both sides by root 3. And again, you cannot leave your answer in this form. That's not good mathematical form. And so you have to rationalize that denominator. So when you rationalize the denominator, remember you multiply by that radical. So we're going to multiply by root 3 over 3. Okay. So I'm going to end up with 6 root 3 over 3. And then that can be reduced. I'm totally out of space. I'm so sorry. Okay, so I hope that helps a little bit. You want to make sure definitely that you have no decimals, that you leave your things in radical form. So I want you to only use radicals and fractions, okay, to get these solved. All right, I hope that helps.